Welcome back, everyone. Struggling with algebraic fractions? You are not alone. But today, we are going back to the basics and simplifying rational expressions will finally click. This is part 1 where we take it slow and clear. Just you, me, and 5 simple examples. Let's dive in and build that confidence. In this video, we will be simplifying 5 simple rational expressions step by step. Let's get started with the first question. Question number 1. Simplify this rational expression. In order to simplify any rational expression, we follow the 3 steps. First one, if possible, we factorize the denominators and numerators. Here in this case, the denominators and numerators are already in the simplest form. We cannot factorize them further, so the first step is not applicable. Step number 2, cancel the common factors from the denominator and numerator. Since you have not factorized the denominator and numerator, so no need to cancel the common factors because the common factors are not there. So the second step is also not applicable in this question. Step number 3, if the remaining fractions are unlike, make them like and simplify further. Let's compare the denominators of these two fractions. Are they same? Very good. They are different. Means the fractions are unlike. Let's make them like. Can you guess how can we make the denominators of these two fractions like or same? Very good. Look at here. The first fraction has p plus q. If I multiply the first fraction with p minus q and the second fraction with p plus q, that is what present in the denominator of first fraction, then they become like, right? If we multiply the denominator, then we have to multiply the numerator with the same factor, remember. So I multiplied the denominator of first fraction with p minus q, so I have to multiply its numerator with p minus q, and so in case of second fraction. Am I clear? Okay, I will multiply the first fraction with p minus q in both denominator and numerator, and second fraction with p plus q in both denominator and numerator. See? P minus q, ultimately they will be cancelled out and remains the question, that is first fraction, p plus q. If I cancel them out, then it gives the original question, that is the previous step. Okay, if you compare the denominators now, you can find exactly same. Means now the fractions have become like. You can simplify further as per your need. In the numerator of first fraction, you have got p square plus pq plus q square times p minus q. If you know the formula of a cube minus b cube, I think you can easily simplify the numerator, right? A cube minus b cube. Can you tell me the formula? A minus b times a square plus ab plus b square. This is the formula, right? And the numerator of first fraction is exactly in the same form. Means I can simply replace the numerator with p cube minus q cube, right? Because in place of a there is p, in place of b there is q, and nothing different except these two alphabets. That's why I can replace the whole numerator with p cube minus q cube. Likewise, can you tell me the formula of a cube plus b cube? It is a plus b times a square minus ab plus b square. Only the difference is the plus and minus. If you go to the numerator of second fraction, Only in place of A there is P, in place of B there is Q, and all other things are same, right? Okay, this means the second fraction can be replaced with P cube plus Q cube. I'll just replace it with the shortcut form because they are in expanded form and write in the next step. Am I clear? Next step, P cube minus Q cube minus Q cube plus P cube. Here, P cube minus Q cube and P cube plus Q cube are kept inside the bracket because there is minus symbol in between the fraction. It has a role to play. That's why you have to be cautious. Let's open the bracket in the numerator. P cube minus Q cube remains same, but this minus and plus multiplies and it becomes minus over here. You can subtract this P cube and P cube and it gives you 0, and minus Q cube gives us minus 2Q cube, right? And in while simplifying the rational expressions, we do not keep the negative symbol in front at the beginning, so we make this negative symbol positive. And in order to make that, you have to have a trick. You have got minus 2Q cube divided by P cube minus Q cube, right? So what you need to do is to make it plus, multiply the numerator with minus 1 and the denominator with minus 1, that is minus. If you multiply, then it changes into plus. Look at here how it changes. Minus minus plus, no need to write it, 2. If you multiply it 1, there won't be any changes in the coefficient, right? So minus 1 into P cube is minus P cube, minus minus plus 1 into Q cube is Q cube. Why we multiplied with minus 1? Because ultimately they will be cancelled out, or dividing minus 1 with minus 1 is 1, so there won't be any changes. Finally, you can write this plus Q cube in front and minus P cube at the back. Same thing I've done over here in the next step. See, 2Q cube divided by Q cube minus P cube, because this Q cube is plus and P cube is minus. And this is our final answer. I believe you understood this. So the second question is y plus 1 divided by y plus 5 minus y minus 1 divided by y minus 5. First step, if possible, factorize the denominators and numerators, and you know it. The denominators and numerators, they are already in simple form though, so no need to apply the first step. Second, cancel the common factors. Again, we have not factorized, means no need to cancel the common factors because there are no common factors in the numerator and denominator. Third step, if the fractions are unlike, make them like and simplify further. Unlike means the fractions with different denominators. See, the denominators are different, right? So if we want to make them same, then this y plus 5 should be multiplied with this y minus 5, and the y minus 5, this one should be multiplied with this y plus 5, right? Then only the denominators become like. And you know, we cannot multiply only the denominator, we have to multiply the numerator as well with the same factors that you have multiplied in the denominator. So if you multiply y plus 5 with y minus 5 in the first fraction, then numerator should also be multiplied with the same factor, okay? Let's do it in the second step. See, here, this y plus 5 are multiplied with this y minus 5 in the denominator and numerator both. And here on the second fraction, this y minus 5 are multiplied with the y plus 5 denominator of first fraction and with the same factors in the numerator. Third step, see, we have got the denominator same, means the fraction are like, so we simplify further, means we work on the numerator, okay? And in numerator, since y plus 1, and this y minus 5, they are in the product form. In between the bracket, there is multiplication, no symbol means, right? So we multiply, means this y multiplies the y minus 5 once, and then again plus 1 multiplies the y minus 5. So how should I write is y times y minus 5 plus 1 times y minus 5. And I multiply it further. Likewise, in the second fraction in numerator section, I have to multiply this y plus 5 with y once, and then again same y plus 5 with minus 5. Finally, multiply y and y, right? Y times y is y squared. This y times 5 is 5y. 1 times y is 1y. 1 times 5 is 5. This is how we multiply and we write. Okay. I have just multiplied all the things and I've written over here. Y. In another step, we simplify. That means we add the like terms and we also open the curly bracket. Look at here. Y square remains same. Minus 5y plus y is minus 4y. Minus 5 remains same. Minus minus y square. And this plus 5y minus 1y is plus y. If that plus 4y is multiplied with the minus present over here, then that becomes minus 5y. And minus times minus is plus 5. Now what happens in the next step is this plus y square and minus y square becomes 0. Minus 4y becomes minus 8y. Minus 5 and plus 5 becomes 0. So finally, we'll get minus 8y divided by y square minus 25. Again, we have got minus negative symbol in the numerator. So we have to make it positive. And our final answer will be 8y divided by 25 minus y square. This is our final answer. Let's jump into the third question. Simplify this expression. Again, we follow the same three steps. First, if possible, factorize the denominators and numerators. Here, in both the fractions, denominators can be factorized. So in first fraction, see, we have got ab minus v square, so v is common. Likewise, in the second fraction, ab minus a square, so there we can take a as the common factor. Let's do that. From the first fraction, I took b as common, so there remains a minus b. And from the denominator of second fraction, a is taken out as common, so there remains b minus a. One thing you should be careful about is if you have got same factors with the opposite symbol, then we try to make them same by taking minus as the common. Like you have got a times b minus a in the denominator of second fraction, right? So if minus 1 is taken out from these two, then this plus 1b becomes minus b and minus 1a becomes plus 1a, right? So I can remove this 1 from the coefficient of a, so it becomes minus a, and plus a I'll write in front and minus b at the back. This is how we change b minus a into a minus b. Okay, I just took minus a in front, that's why b minus a has become a minus b. Now this minus and plus, I can multiply them and the symbol at the middle becomes minus. Likewise, if we compare the denominators of these two fractions, they are different, means they are unlike. And we can make them like a minus b and a minus b, they are common factors, like, right? Only the first fraction has b extra and the second fraction has a as the extra factor. So if I want to make them like, then I can multiply the first fraction with a and the second fraction with b. See, I multiplied both the numerator and denominator of first fraction with a and that of second fraction with b in order to make the denominator same. Now the fractions are like, so I can simply simplify the numerators. Means in the numerator 1 times a is a and 1 times b is b. Now I have got same fraction in the numerator and denominators. I can cancel them. So finally I'm left with 1 over ab, which is our answer. Let's do the fourth question. simplify this question. As I told you before, if there are same factors but only the symbols are opposite in the middle, then we can make them same by simply taking minus as the common. If three consecutive alphabets are involved, then we can make the subtraction a cyclic one. Means like x, y, and z are the three consecutive alphabets, right? So x comes before y means we can subtract y from x. Likewise, we can subtract this z from y because z comes after y. And in a cycle, this x comes before z, so we can subtract z from x. Means our factors look like x minus y, then y minus z, and then x minus z. Okay, so if the factors are in such orders, then we do not make any changes. But in place of x minus y, if we are given y minus x, then we change it to the x minus y. Z minus y, if we are given, then we change it to y minus z. And if we are given z minus x, then we change it to the x minus z. So it simplifies the process. In our question, we are given z minus x, so we have to convert it into x minus z. And we are given z minus y, but it has to be y minus z, so we change it to y minus z by taking minus 1 or minus as the common. Let me show you how this z minus x times z minus y can be changed. So z minus x, I need x minus z. So I will take minus 1 common from it. If I take minus 1 common from z minus x, then this plus z becomes minus z, and then this minus x becomes plus x. Okay? And if I take another minus 1 common from this z minus y, then this plus z becomes minus z, and then minus y becomes plus y. Finally, I can multiply this minus 1 and this minus 1, which is minus times minus is plus, 1 times 1 is 1, so no need to write it. Minus z plus x, I can write x minus z, and then minus z plus y is y minus z. This means if there are two such factors where sign has to be changed, then we can simply change it without making changes in the symbol present in the middle. If there is only one factor where the sign needs to be changed, then we simply change it and change the symbol present in the middle. Okay, this is the trick. Okay, now in the first fraction there is x minus y, which is not present in the second fraction. So I need to multiply second fraction with x minus y. Likewise, in the second fraction there is y minus z, which is not present in first fraction. So I need to multiply first fraction with y minus z. Let me multiply and write. This is how our solution look like. I multiply the first one is y minus z because it is not present in the first, but it is present in second. And I multiply second fraction with x minus y, which was present in the first fraction. Now, if you look into the denominator, they're exactly same. Means we simply can perform the operations in the numerator. Okay, multiply y minus z with the 1 present in front, x minus y with the 1 and plus present in front. Let's do that. Nothing happens, just we write y minus z plus x minus z. Now this plus y and minus y is 0, right? Y minus y is 0. And minus z plus x, I write this plus x in front and minus z at back. So our next step is x minus z over whatever present in the denominator, same thing. Now x minus z, it is present in the numerator as well as denominator, so cancel them out. What remains in the numerator? If you divide it, then there remains only 1. So our final answer is 1 over x minus y times y minus z. Done. Let's move to the fifth number. Fifth number has two questions. This is what we have to prove in first one, 5i. And since this is the question to prove, so we take the left hand side and we simplify it and we try to reach to the right hand side. Let's take the left hand side first. We simplify it and try to reach to the right hand side to prove. And first step, if possible, factorize the numerator and denominator. First fraction, it is already in the simplest form. Second fraction, I think we can factorize the numerator and denominator. Right. Let me try x squared minus x plus 2. Here only possible way to factorize is by splitting the middle term. Middle term is 1. So if you have to form 1x by using the factor of 2, 1 is 2. And since there is plus, by adding these two factors, we have to make a 1. That is not possible. So if it was minus, we could factorize it, but it is plus, so we cannot split the middle term. Means the numerator is not possible to factorize. Let's move to the denominator. We are given x squared minus 2x minus 3. So we have to use the two factors of 3. 3, 1 is 3. And by using these two factors, since minus is present in front of the last term, so by subtracting these two factors, I have to make this 2. Is it possible? Yes. That means we can factorize it. This 2x can be split into 3x minus 2x. Let's split and write it. Since the process becomes longer if I factorize in the next step over here, so I'll show the factorization process on the right hand side separately. Remember, this factorization process is not the rough work, it is the part of our solution. So if you are doing the factorization separately, make sure that you'll keep on the right side of your solution. This is the factorization of denominator. X squared minus 2x minus 3. By using the three factors, we can split this 2x as 3x minus 1x. If I open the bracket, this 3x remains same. Minus times minus is plus 1x minus 3x. X is common in the first pair and 1 is common in the second pair. Ultimately, our factors are x minus 3, x plus 1. So we keep these two factors in the denominator of second fraction. See? Now let's compare the denominator. Are they exactly same? I don't think so. They are different. They are unlike. The first fraction has x minus 3 in the denominator, but second has two factors. So if I multiply the first fraction with x plus 1, I think the fraction becomes like, right? So let's multiply. Now the fractions are like. We simply perform the operations in the numerator. X minus 1, x plus 1. It is in the form like a plus b, a minus b, right? Which is the formula of a square minus b square, isn't it? Likewise, if you are given like x minus 1, x plus 1, isn't it x squared minus 1 square? Means 1 square is 1 itself, means I can write x squared minus 1 in place of x minus 1, x plus 1. And second one remains same. But make sure that you'll keep it in bracket or you multiply inside each symbol with this minus and write the final answer, okay? Let's open the bracket. So this minus and minus multiplies and it becomes plus. This minus and this plus multiplies and it becomes minus. Finally, x squared and minus x squared, 0. And other things I think we cannot do further, like this plus x I have to write in front. Minus 1, minus 2, it becomes minus 3. Okay. X minus 1 minus 2, 3. Now I've got minus x minus 3 in the numerator and x minus 3 in the denominator. Let's cancel that. So there remains 1 by x plus 1, which is RSH, which is the expression given in right hand side. See, we started from the left hand side, we performed the simplification, and finally we reached to the right hand side, means proved. This was 5I. First question of question number 5. Let's do the second question, which is similar to this one. Again, we start from the left hand side. We factorize the all denominators and numerators if possible. Means the first one is a square minus 3ab plus 2b square. We need to split the middle term. Like this 2, we factorize 2. 2, 1 is 2, right? And since there is plus, so by adding these two factors, we need to form 3, which is possible. So we can split this 3ab as 2ab plus ab. Okay, open the bracket, means 2ab plus minus times plus is minus here, and then take a common in the first pair, b common in the second pair. So your factors are a minus 2b, a minus b. So the numerator of first fraction will be replaced with a minus 2b, a minus b. Likewise, this denominator can also be factorized, which is a square minus 4b square. 4 is the square of 2, so it becomes 2b whole square. Now it has converted into the form of a square minus b square. So you can expand it as a plus b, a minus b. That is a plus 2b, a minus 2b. Likewise, this 4a square plus 8b square, simply we can take 4ab as common, and there remains a plus 2b as the other factor. We replace all these numerators and denominator with the factors that we have calculated right now. Okay, see, just replaced with the factors. Second step, if possible, cancel the same factors present over the denominator and numerator. Let's cancel it. A minus 2b and a minus 2b it is present, right? 4a and 4a present. There were 2b's and 1b in the denominator, so 1b will be cancelled out. Let's write the remaining. A minus b by a plus 2b minus b by a plus 2b. See, we already got the like fractions, right? Denominators are same. So just perform the operation in the numerator. A minus b minus b. Minus b minus b is minus 2b, which is the right hand side. Started from the left hand side, reached to the right hand side, means we proved the given expression. And there you have it. 5 beginner-friendly problems to kickstart your journey with rational expressions. If you found this helpful, hit the like button and subscribe so you don't miss part 2, where we'll take on slightly trickier problems. Drop a comment if you want me to include your requested questions in the next video. See you soon. And remember, math makes sense when you break it down.